Recording you now. All right, so we need to express these in logarithmic from exponential. So we're going to do this one and this one because we've already done it before. Okay, so we're going to do this one and this one. I'm going to do the first one. So we have to convert this to a log. So we write the word log. It's crazy, I know. Now, we need to have three pieces of information to be able to convert. What's the base of my exponent on this one? It's the 2. So we get log base 2, and then what goes beside it is what's not friends. So what goes beside it? 1 over 16, and it equals negative 4. We're done. We just wanted to convert it. You do D. All right. The base of my exponent becomes the base of my log. So I get log base what? This is the base of my exponent because here's my exponent, right? So I get base 2x plus 4. Then what's with it doesn't stay with it. So what do I get beside it now? A, and it equals the exponent, which is negative 1. Done. Okay, flip it over. Now we're converting the other way. So say I look at this one and this one. What's the base of my log for C if I don't have a base? I've already told you this before. What is the base if there isn't a base? 10. So we put a base 10 down here. Just like the square root symbol, when we take the square root of something, if I don't have an index, you know that the index is a 2. It's likened to logs. If there's no base, it's base 10. That's what they always do, because a lot of the stuff like pH scales or earthquake Richter scales are all base 10. So that's why they picked log base 10 because it's the most common use. Same thing with square roots are most common use, so that's why they left the index off for the 2. But 3, 4, and 5 are a little less more awkward. Okay, so we have to convert this to exponential. So the base of my log becomes the base of my exponent. In order for it to be a base of an exponent, it needs an exponent. What's its exponent? 3. And then it equals 1,000. Because remember what's friends? From one to the other isn't. So these two are friends right now, currently 10 and 1,000, so they won't be when I convert. You do D. Okay, we're not solving anything. What's the base of my log? K. What's going to be its exponent? X. And what's it going to equal? T. And then we box it because we're proud of it. Okay. We also learned this already, so this is all just repeat. When I put log base 2 of 8 into my calculator, what is it doing? It's doing 2 to what power is 8? What's the answer? 3. And then this one's saying 2 to what power is 4? 2. And then this one's saying 2 to what power is 2? 1. Then this one is 2 to what power is 1? 2 to what power is 1? 0. 2 to what power is a half? Negative 1. And 2 to what power is a quarter? Negative 2. Now with that knowledge, answer these. So we'll do the first one together. Log base 3 of 9. So that's 3 to what power is 9? 2. Done. You do the rest. Go. So 4 to what power is 16? 2. 5 to what power is 125? 3. 3 to what power is 27? 3. B to what power is 1? 0. And B to what power is B? 1. Now guys, we can remember this one 2 different ways. If I give you log base, let's say 4 of 7, and you had the old calculators, you would have to type it in as log 7 divided by log 4, correct? Yes. So if I gave you log base B of B, we could technically type that in as log B divided by log B. What's anything divided by itself? 1. So that would also get us 1 as well. Okay, then we're flipping over. We've done a lot of this already, so we're just picking some of these. So here, we're going to actually solve. Go. All right, so we get 3 pieces of information. So we get log base 4 of 7 equals 2x minus 1. Then I'm going to add my 1 over. and I get log base 4 of 7, close the bracket, plus 1, and then I divide by 2. Now, the problem with logs and exponentials is not that they're difficult. The problem sometimes is that you get to match the answer they have. So what they might not do is divide the whole side by 2. They might just divide each term by 2. So watch yourself. They could have went like this. Log base 4 of 7. That is one term, correct? Because there's no plus or minus sign happening. And then plus 1. That's another term, correct? Divided by 2x. They might do this. I have the same color. That is useless. Anyways, who cares? Divide by 2, divide by 2, divide by 2. So what I actually get, instead of dividing by 2, I put a half in front. Log base 4 of 7 plus a half. Why would this be helpful, this form, as opposed to this one, as opposed to this one? What is this form helpful with, guys? Using your brain cells. Dig deep. Let's figure this out here. Why is this more helpful in some ways than that one? Something we learned in the second unit. What was our second unit? Starts with a T. Transformations. Is this, we did not. Is this form better for transformations? Vertical stretch. And then this would get me my whatever, and then this would get me whatever. Like I have to have an X in there, but this can get me in transform form. So what you need to know anyways is, cool, you like this one better. That's great. This is the one they gave on the test. You have to be able to find the forms that they have. That's the hardest part about logs and exponentials. It's not that people don't understand what they're doing. It's that you can't figure out how to make yours look like the way they did it. It's like them saying, Tommy did it this way, figure it out. And you're like, I don't friggin' know how Tommy did it. My way's better. Cool. You got to figure out how Tommy did it. You got to match Tommy's ways. Okay? And then this one, can we divide the 5 over? When people are like, I don't know, okay, 10 divided by 5, is that legitimate math?
Oh.
Yes, in grade 3 we agree that you can do 10 divided by 5. So that's legitimate. But if 10 had like an x plus 3 on it, we wouldn't be able to do it. Okay? But 10 divided by 5 is 2. We know that. That's like my daughter could tell us that. We know that's real math. So we get 2 to the 2x minus 1 equals 2. We could do common base here and make that be a 1. Or we could convert. Log base 2 of 2 equals 2x minus 1. Log base 2 of 2 is actually 1. So I get 1 equals 2x minus 1. Add 1. 2 equals 2x. Divide by 2. X equals 1. All right. Then we're going to flip over. Time out. Hint, divide by 2. Hint, divide by 2. So, when your base has the variable in it, it's way harder to solve. It takes more, it's not way harder, it just takes way more work. When your variable's beside the log, it's a lot easier, just solving algebraically. Now listen, what you need to know is that your base and what's beside your log can never be negative or 0. So if when you plug them back in, it makes them negative or 0, they're extraneous. And log equations often get extraneous roots a lot. Okay? So let's look at this one. First thing you'd have to do is divide by 2. So now I can convert it. So I get the base, which is 2x minus 1 to the exponent 2 equals 6. And what do I do when I take a square root? When I do this with my arm? What do I have to remember to do? Positive and negative signs. So when I do this, I get plus or minus. And you have to show that work. And you have to show the extraneous. And sometimes they might just ask for just the extraneous. Because I could type that into y1, y2 and get an answer, could I not? But what answer will never show up if I type it into y1, y2, the extraneous one. So I'm going to get 2x minus 1 equals plus or minus root 6. Add the 1 over. 2x equals 1 plus or minus root 6. And then I divide by 2. The catch is, this gives me 2 solutions. 1 plus root 6 divided by 2, and 1 minus root 6 divided by 2. Now, 1 plus the square root of 6 divided by 2 is approximately 1.72. Now, if I plug that back in, 2 times 1.72 minus 1 gives me a positive number, correct? And I can plug it back in and it will work. This is good. This is the exact value, that's the decimal, depends on what I asked you for. 1 minus square root 6 divided by 2, however, gets me negative 0.72. Now, if I go 2 times negative 0.72, and then I subtract 1 from it, my base will be negative 2.44. Am I allowed to have a negative base? When I plug that in for x, I'm going to get negative 2.44 here. Am I allowed to have a negative base? No, I'm not allowed to have a negative base, and I'm not allowed to have negative beside the log. So if there's a variable here and it makes it negative, I can't have that happen either. So you check it back, and if it makes a negative base or it makes negative beside the log, you circle it, put a line through it, and say extraneous. Now this one's a lot easier because the exponent or the variable is not in the base. So now I have, so the base of the log is 3, its exponent is 2, and it equals 2x minus 1. Now I'm not having to take the fourth root or the square root or any of that jazz, which takes way more work. So then I get 9 plus 1 equals 2x, divide by 2, and x equals 5, and I always double check. When I plug that in, 2 times 5 is 10, minus 1 is 9. So that's good. I can have a 9 beside my log. And then I can go 2 times 3. Log base 3 of 9 is 2. 2 times 2 is 4. So it's right, and it works. These ones down here are extra logarithm rules to note. And I put stars, and I put it as their own caveat. I used to not, because they're ones that everyone forgets about, especially if they're given with variables. So if I ever have log base a of a to the m, my answer is just m. Because how is your calculator doing it? It's going a to what power gets me a to the m, which is just m. So what that means is if I get like log base 2 of 2 to the 3, my answer will be 3. If I get log base 7 to the 5, my answer will be 5. Okay? The other one that everyone forgets about is if there's a 1 beside the log. So a to what exponent is 1 is 0. People will sit there and they can't realize that it's a 0. Remember, if I give you variables, I have to tell you like a has to be greater than 1 or a has to be greater than 2. You could plug in numbers and see if you get out the same answer constantly, right? And then this one, it happens rarely, but I bring it up just in case. If the base of your exponent is the same as the base of the log in your exponent, your answer is what's beside it. So let's go through and do these ones. So log base 5 of 5 to the 6. What's the answer to that one? 6. This one I could rewrite as a base 2. So I could go log base 2. What's 1 over 32? 2 to the what? What's 32? 2 to the what? 5. So 1 over 32 is 2 to the negative 5. So now I have log 2 to the 2 to the negative 5. What's my answer? Negative 5. What happens when I have this? 5 log to the exponent log base 5 of 25. It's just 25. And then I box my answers because I'm proud of them. And then what about this one? Log base x of 1. It's 0 because x to what power is 1. So whenever you have that 1 beside your log, the answer is 0. Okay, we're going to flip over. Here are some diploma style questions. I want you to try all 4. I'm going to give you a little bit and I'm going to start putting up some answers as we go along. I also have the homework is right here. It's not very long. 20 to 23 literally is one question each. And then I have a cumulative assignment 3 I'm going to hand out that's due on Thursday. Because after this unit exam is your cumulative. So these are the 4. I'm just recording them really fast.